Okay, lesson 4, ADM 7, simplifying square roots. This is pretty much an exercise in learning a skill, learning how to do an exact certain thing, which is simplifying square roots, and then just practicing over and over. Not a lot of word problems in this lesson. It's pretty much a procedure. We're going to learn how to do it. We're going to practice it and be done. Okay, let's head on over to our sketch screen and get with it. Okay, so there's two key things that you need to know for this whole lesson, and then everything else is going to be building blocks that should be very familiar. But, okay, the two new things you're going to need to know is the concept of a square root is simplified when the radicand does not have any perfect square factors. Okay, we're going to talk about what that means. The radicand, if you recall, the radicand is the number underneath the square root. So that in the square root of 12, the number 12, this is called the radicand. And I think I've used this word before, but this is the official word or the official definition of a radicand. It's the number underneath the square root or the radical sign. All right. So when I use the word radicand, you now know what it means. If that number does not have any perfect square factors, it is simplified. But if there's any factor in here that is a perfect square, then it needs to be simplified by rule. The second thing is that the square root of two numbers multiplied together is the same thing as the square root of the first factor times the square root of the second factor. Well, I'm going to show you how to apply both of these rules as we learn to simplify the square root of 12. Again, these two building blocks is everything that we're going to do today depends on them, and we're going to practice over and over. So the question is, first question is, here's the problem. Simplify the square root of 12. Okay, now the first question, is it simplified? Because if it's simplified, then we're done. For example, well, we won't do the counterexample yet. Is the square root of 12 simplified? And the answer is no, it is not simplified. And why is it not simplified? Well, the reason is it has 12. I'll just use the number. No, because 12 has a perfect square as a factor. Can anyone tell me what that perfect square is? Turn on your brains. Well, it does. The perfect square factor in 12 is the number 4. Because 4 is a factor of 12, it is not simplified. So 4 times 3 equals 12. Okay, so we know it needs to be simplified, so we need to simplify it. So the way that we simplify it is we will separate it into the square root of 4 times 3. So the square root of 12 equals 4 times 3, the square root of 4 times 3. And that makes sense because you just think of it like this. Okay, so nothing magic yet. Now we're going to use our second rule, our second key rule for simplifying square roots. Now that is that two numbers, the square root of two numbers multiplied together is the same as the product of the square roots of each of the numbers. So I can just do this. The square root of 4 times the square root of 3. And I haven't proved that rule, but that rule is true. Now what we can do is we can say, well, we know what the square root of 4 is, and that's 2. And the square root of 3 cannot be simplified any further because 3 has no perfect squares as a factor, other than 1, but that doesn't count. So the square root of 12 equals 2 root 3. And this is simplified. Okay. Now, all we're going to do is we're going to do this over and over today. That's the entire lesson. We're going to do about 6 or 7 examples. I'm going to work them. There's 1 or 2 little tricks I'm going to need to teach you, but otherwise, that's the lesson. If you know how to do it, you can just hang up, as they say. We're going to put down a happy cat. Oh, the happy cat's not working. Let's see, that usually gets the happy cat working. Let's see, one more time. There's our happy cat. Let's put him over here. And then we're going to move on. Okay, so now we're going to simplify these numbers. I'll simplify. We'll do it in green just to change up the color. So now the whole key is we're going to find the perfect squares in the radicand. Then we're going to separate, simplify, and then repeat if necessary. Those are our steps. Okay, now what I'm going to do too, when I used to do this in math class, I would just do this. I would write all these perfect squares down on the side. That's 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 5 squared, 6 squared, 6 squared, 7 squared, 8 squared, 9 squared, and 10 squared. And you can keep going up higher if you want. But we're just going to write those ones down. And the reason we're going to do that is because if we see any of these factors in these numbers over here, then we know that we don't have a perfect square, that we don't have a simplified radical, and we need to then simplify it. And I'm going to tell you all of these need to be simplified, all of these examples. So let's see. And we want to generally try and get the biggest number we can, but it's not imperative. And we'll see that in some cases we need to repeat when we get to the end of our calculation and do it again. So we always have to check at the end and make sure that our radical piece is indeed as simple as it possibly can be. So let's see. So the biggest, what number goes into what perfect square is hiding inside the square root of 28? Well, it's not 36 because that's bigger than 28. It's not 25. It's not 16. It's not 9. So it's 4. 4 does go into 28. So I'm going to rewrite this as 4 times 7. Now we're going to use our split rule and say that's equal to the square root of 4 times the square root of 7. All right, we found our perfect square. That's step A. B, we separated. And then we used our rule here. Now we're going to simplify. And the square root of 4 simplified is 2. And that's times the square root of 7. Now we need to ask ourselves, is 7 simplified? Is there any perfect squares inside 7? And the answer is no. So this thing is indeed simplified. Now let's do the same thing with 50. Well, 4 doesn't go into 50, 9 doesn't go into 50, 16, 25 goes into 50. So that's equal to 25, and then what's left over? 2. So now we're going to split them into 2 radicals. The square root of 25 is 5 times the square root of 2. And the square root of 2 is as simple as it can be. Now, we're going to do the square root of 48. It turns out there's a couple factors that can go into it, but I'm going to show you it doesn't matter which one you use. If as long as we remember this D step. Okay. So let's see. 4 goes into 48. So let's do that. Let's go the square root of 4 times 12. Right? 4 times 12 is 48. 4, we found our perfect square, and what's left over is 12. So now we split it out, and we go 4 times the square root of 12. We say, well, that's equal to square root of 4 is 2, square root of 12. Now the question is, are we done? Now, here, I'm going to write this out. I'm going to write this out. Are we done? And for those of you that said no, you are right. And it's because the square root of 12, or 12, has a perfect square inside it, right? So the square root of 12 is not simplified. So we have to keep going. So let's keep going. So we have 2, there's our 2, times 12. 12, what's hidden inside there? Another 4. So 4 times the square root of 3. There's our 12. There's our hidden perfect square. And so that's equal to 2 times the square root of 4. We're going to separate out using our rule. Our 4 and our 3. And then this is a 2. So that's 2 times the square root of 3. And that's equal to 4, because this is equal to 4 times the square root of 3. And now we're done. Now I want to show you what would have happened if you could have found the biggest perfect square that goes into 48. And which is that one? Well, it's not 4, it's not 9, it's 16. So for those of you that saw that 16 goes in, watch what happens. 16 goes in 3 times. So 16 times 3 is also 48. And here's our perfect square, our PS, our perfect square. So that's equal to the square root of 16. And when you guys see how cool this is, scream out, "That is so cool, Mr. Lipscomb." Because the square root of 16 times the square root of 3 equals 4 times the square root of 3. And now we're done in 1 step rather than 2. And notice, because math is perfect, we get the same answer. If we start with the square root of 48, we better end with the same answer. Whether we went the long way and had to do 2 steps, or whether we went the short way in 1 step. Okay. Now let's go and let's do a few harder ones. And I'm going to let you try these. And it's okay. Let's see. It's okay if we get these in more than 1 step. All right. I'm going to write these factors down over here to help you solve these problems. And when I solve them, just know that you may go in 1 step or 2 steps or 3 steps. But as long as you get the same answer, it's all okay. So I'm going to let you pause and try these 4. And you may need, remember, you may take 1, 2, or more steps. Okay, now I assume you're back. I assume you've tried these and practiced them. And let's see if we can make heads or tails of how to do these problems. Well, I can see quickly on A that 100 will go into 600. So here we got the square root of 100 and times 6. So that is equal to the square root of 100 times the square root of 6, which is equal to 10 root 6. Some of you may have taken out a 25. Some of you may have taken out a 4 first, but it doesn't matter what you did here. You still would have ended up with 10 square root of 6 after doing it multiple steps. Let me show you what would happen if you took out a 25. You could have said, well, that's equal to the square root of 25 times 24. And that would equal 5 root, well, let's just do it, write it all out. Square root of 25 times the square root of 24. And that would equal 5 root 24. And the problem here is the square root of 24 has a perfect square inside it. So you'd end up with 5 times the square root of 4 times 6. And that's equal to 5 times the square root of 4 times the square root of 6, which is equal to 5 times 2 times square root of 6, which is equal to 10 root 6. Okay, if you would have also taken out a 4 first, you would have ended up in the same place later and having to take out a square root of 25 later. But whatever, 10 square root of 6. All right, let's do square root of 72. Here we get, oh, this one's a big one. We can take out a 36 out of 72. Some of you may have taken out a 4 first, or maybe taken out a 9 first, but I'm going to take out a 36 first. 36 times 2 equals the square root of 36 times the square root of 2, which is equal to 6 root 2. All right, 180. 180. Let's do it. Let's try this. I see that a 9 comes out. So we're going to do the square root of 9 times 20 equals, so that equals the square root of 9 times the square root of 20 equals 3 root 20. But are we done? You got to go back and look at that radicand, and I see that there's still perfect squares hiding inside there. Well, it's not a 16 and not a 9, but a 4 will come out of there. So we got 3 times the square root of 4 times 5. So it equals 3 times the square root of 4 times the square root of 5, which is equal to 3 times 2 times the square root of 5, which is equal to 6 root 5. Getting the hang of this? Hope so. Uh-oh, this is a mess. That's a huge number. Uh-oh. I don't know. I don't know here. Well, let's see. A 4 won't actually go into this number. Will a 9 go in? Yeah, a 9 will divide in here because a 9 will go into 48. Yeah, see, a 9 will go in 486. A 9 will go in 5 times. 5 times 9 is 45. 36, 54 times. So notice you just got to try all these numbers. And so I tried 9, and I know 9 goes in 54 times. So this is just kind of like prime factorization here. You got to just try numbers out. So 9 times 54. So that equals the square root of 9 times the square root of 54. So that equals 3 times the square root of 54. And so you have to ask yourself right now, are you done? Are you done? Are we done here? Well, no, because 9 will go into 54. 9 goes into here. So we say, well, that's 3 times the square root of 9 times 6. We had another perfect square. So we go 3 times the square root of 9 times the square root of 6. So that equals 3 times the square root of 6. And so that's 9 root 6. Wow. Let me write that nicer. Okay, and what does that deserve? That deserves a happy cat. What the heck is going on with my happy cat? My happy cat is not working. Why not? Why isn't my happy cat working? There we go. We got happy cat working. We got happy cat working for us. Happy cat, happy cat, happy cat, happy cat. We get a happy cat because we did that one twice, 2 different ways. And now we have one final set of questions that builds on top of our knowledge of the Pythagorean theorem and is on your homework. So let's just make sure that we know how to do these as well. So we have our A side. Okay, so let's pause and try. And you're going to use the Pythagorean theorem. Pythagorean theorem. Remember, a squared plus b squared equals c squared to solve these guys. Okay, so I assume that you've paused and you've tried these. You've tried to simplify. Both of these are going to require simplification, by the way. So we have our a side and our b side and our c side, and over here we have our a side, our b side, and our c side. So let's write this down. A squared plus b squared equals c squared. So that's 4 squared plus 4 squared equals c squared. So that's 16 plus 16 equals c squared. So that's 32 equals c squared. So let's take the square root of both sides. So c squared, the square root of c squared equals the square root of 32. And so the square root of c squared is c. So the square root of 32 can be simplified because, let's see, let's write our numbers down over here. 4, 9, 16, 25, 36. Well, because a 16 will go in. So we get the square root of 16 times 2, which is the square root of 16 times the square root of 2, which is equal to 4 root 2 equals c. So this is 4 root 2. And it's an interesting thing that you can show, or you can prove, or you can try it yourself. But if you ever have a triangle where you have two sides that are the same length and they're the legs of a right triangle, that the long side is always going to be that short side, either of the short side times the square root of 2. So if I had a triangle like this, which is 3 and 3, this is going to be 3 square root of 2. And you can use that, you can always show that using the same method. It's kind of cool how it works out, and you can kind of satisfy yourself with this. So we can even go one step further and say, well, if both sides are x, this is going to be x root 2. And that's the more general form of what I said. Any right triangle where the two legs are the same length, the hypotenuse is x times the square root of 2. All right, let's go on and do this last one. And let's just do this last one in orange, just because we can. So a squared plus b squared equals c squared. So that's 24 squared, a squared, plus 16 squared, anyone? 256, equals 24 squared. 24 squared is a tough one to remember. I think it's 596. I'm just going to write it down and then go ahead and use my calculator because I like to see if I remember these correctly. No, it's not 596, Mr. Lipscomb. It is 576. So a squared plus 256 equals 576. So let's subtract 256 from both sides. And we'll get a squared equals 0, 2, 3. The square root of 320. So we take the square root of both sides, and we get a equals the square root of 320. Well, the square root of 320, let's see, what goes in there? How about a 16? Yeah, 16 goes in, times the square root of 20. So that's equal to the square root of 16 times the square root of 20, which is equal to 4 root 20. But the square root of 20 has hidden square roots inside it. It has a 4, another perfect square. So we got to keep going. So 4 times 4 times 5. So that's 4 times the square root of 4 times the square root of 5, which is equal to 4 times 2 times the square root of 5 equals 8 root 5. So this is 8 root 5. And our happy cat is not working well today. Oh my goodness, driving me crazy. Driving me crazy. Happy cat, happy cat. I'm going to double happy cat that one. That was a lot of work. Okay, we are now done. We've worked a lot of problems, a lot of samples, done some good work, simplified square roots, and we're going to move on, and we're going to have 8M7 lesson 5 tomorrow. Hopefully this was helpful to you. Thank you for clapping. Love it. Love teaching math. See you next time on Happy Cat, Happy Math. Happy Life.